So now what I will show you next, and this will be discussed at several points during the course, is that writing multi-threaded processes is challenging. Writing code that can be executed by multiple threads puts a lot of pressure on programmers because of several challenges. You have some of them here. But before we look into these challenges, we need to understand the difference between parallel execution and concurrent execution. This is extremely important. Parallelism implies that a system can perform more than one task simultaneously. Concurrency supports more than one task making progress at the same time. So the operating system, your computer, together with the operating system, can have several threads that are making progress during a certain period of time. To show you what this means, let's have a look at this. So here we have 4 threads. In the first case, we have a single core, and we see that over time, the 4 threads are all being executed. This is a concurrent execution. If you freeze time and you look inside the core, you will find one thread executing, so running one line of code from one process. There is only one thread at a time, and so one process at a time that is being executed. The execution is concurrent, the execution of the different threads. When we talk about parallel execution on the other end, we are talking about a system in which we have multiple cores, and at the same instant of time, so if we freeze time and we start looking inside the cores, we can find more than one instruction that is being executed at the same time, okay? So in this case here, you can see that the thread 1 and thread 2 are being executed in parallel, while here, thread 1 and thread 2 are being executed concurrently, okay? Now, when we have parallel execution of multi-threaded processes, we can go in 2 ways, usually. One is to take advantage of multiple threads to perform data parallelism, okay? In this case, we might, for instance, I don't know, look for an element inside an array, okay? And instead of having one thread that searches the entire array, I have 2 threads, each searching one half of the array. In this case, it might be that 2 distinct threads are actually running the same lines of code from the same process. And this I mentioned in some video before. Multi-threaded doesn't mean that you are executing different parts of the process. You might be executing the same part, but on different data. An alternative to data parallelism is task parallelism. So in that case, you distribute different tasks to different threads. So you can have a thread checking for updates, another running the spell checker, and another one printing documents and so on. If we go back to our example about Microsoft Word, okay? As we will see, CPUs have cores as well as hardware threads. There is architectural support for threading, okay? You have mechanisms such as hyper-threading and so on. So this I'm mentioning because, as I said in the beginning, and I will repeat several times, there is a tight connection between the operating system and the hardware that is designed to be compatible and in line with modern operating systems.